Welcome to an intro to boundary value problems. So the general idea here is so far we have studied initial value problems. So far we have studied initial value problems. Such as y double prime plus, I'm going to do a specific one, y double prime plus lambda times y is equal to 0. With initial conditions y of 0 is equal to some initial condition y naught. But actually, let's go with k naught. And y prime of 0 is equal to k1. So where both of our conditions were on the initial value for t. So where both initial conditions apply to an initial t naught. Now we're going to look at instead where one condition will apply to a beginning t naught and one condition will apply to an end t1. So now we will focus on problems where we have a condition at the beginning of an interval and a condition at the end of the interval. We will focus on one specific differential equation with a whole series of of boundary conditions. So we will focus on differential equations of the form y double prime plus lambda times y equals 0. The reason being this will have applications in various partial differential equations. I need to give myself a little space, one moment. So as I mentioned, that's y double prime plus lambda y equals 0. This appears in the solving of various partial differential equations. Particularly, we'll be focusing on ones in physics and engineering. So we are going to focus on y double prime plus lambda y equals 0 with a variety of possible boundary conditions. So our various boundary conditions that we will focus on, option 1 will be the case where our initial boundary is 0, and we're looking at y of 0. And then this is equal to y of l, our end boundary, both of which are equal to 0. My screen is not updating, apologize. Again, our first case where was our two boundary values, our two boundary values of t, 0 and l. When we take y, we just get 0. So y of 0 equals y of l, both are equal to 0. Our second case would be y prime of 0 is equal to y prime of l. Again, both equal to 0. Our next case will be y of 0 is equal to y prime of l is equal to 0. So we have a mixed conditions. Our next case will be y prime of 0 is equal to y of l is equal to 0. And then our last case will look a little different. Our last case, instead of going from 0 to L, we are going to go from negative L to L. And here we have y of negative L is equal to y of L will be one condition for the boundaries. And our second condition will be that y prime of negative L is equal to y prime of L. So these are the possible different sets of boundary conditions we will be focusing on. So I should say with a variety of possible boundary conditions. So these again will be the ones that we are focusing on. So just a little vocabulary to deal with. Definition. Lambda is an eigenvalue of a boundary value problem. Again, we'll focus on y double prime plus lambda y equals 0 with whatever boundary conditions. Plus one of the 5 boundary conditions. If the problem has a non-trivial solution. So if the problem has a non-trivial solution for that value of lambda. Just like we have eigenvectors corresponding to eigenvalues for matrices, we here will have eigenfunctions corresponding to eigenvalues. So we say that phi is an eigenfunction corresponding to lambda. Sorry about that. Trying again. Phi is an eigenfunction corresponding to eigenvalue lambda. If Phi is a non-trivial solution for the boundary value problem with that value of lambda. So if phi is a non-trivial solution to the boundary value problem, with that value of lambda. In the next video, we will do some actual examples with eigenvalues and eigenfunctions. So if these are slightly confusing definitions here, they will make more sense with the examples.